Welcome to the video on binomial theorem and Pascal's triangle. First, we'll learn about the binomial theorem. So the binomial theorem shows how to expand binomials to a power. So this is what a binomial is right here, because it has two terms and it's raised to a power. So to figure out how to expand it, you do the sum from k equals 0 to n of n choose k. So this is, down here it's this n choose k, which is a combination, which we'll learn about in the next video. But what that comes out to be is n factorial over k factorial times n minus k factorial. So this exclamation point, that's a factorial. So it means the number times all the numbers smaller than it. So if we had 3 factorial, that's 3 times 2 times 1. And if we had 5 factorial, it would be 5 times 4 times 3 times 2 times 1. So that's what the factorial is. So we're going to have n choose k times x to the n minus k times y to the k. So you'll understand a little bit more of what that means as we go through an example. So then we also have our binomial coefficient. So that's this n choose k, and that's a combination. So here's our example. It says expand x plus y cubed. So x plus y cubed would be x plus y times x plus y times x plus y, which is quite a bit of work when you have to distribute everything and do that over and over, especially when this exponent gets larger. So that's why we use our binomial distribution equation. So we're going to do the sum from k equals 0 to n. So in this case, n is 3. So k equals 0 to 3 of n, which is 3, and then choose k, times x to the n, which is 3, minus k, times y to the k. So we're starting with k equals 0. So we have 3 choose 0 times x to the 3 minus 0, and then y to the 0. Then we'll go up to k equals 1. So you do plus 3 choose 1, because k is 1 now, times x to the 3 minus 1, y to the 1, plus, now k is 2. So we have 3 choose 2, x to the 3 minus 2, y to the 2, plus, now we have k equals 3. So this is going to be our last one. So we have 3 choose 3, x to the 3 minus 3, y to the 3. So we can go ahead and simplify this. So 3 choose 0. We can use our combination for that. So this equation for our binomial coefficient. So we have n factorial, so 3 factorial over k factorial, which is 0 factorial, times n minus k factorial, so 3 minus 0 factorial. So that's equal to 3 factorial over 0 factorial is 1, and then 3 minus 0 is 3, so 3 factorial. 3 factorial over 3 factorial is just going to be 1. So we have 1 times x cubed. Y to the 0 is just going to be 1, so you just have x cubed as your first term. X cubed. We can also figure out these combinations using the calculator. So the way you would do it with your calculator is you would select math and then go over to probability and then down to NCR. And then you would enter in the top number as n. So like for this one, it would be 3C1. And when you put that into your calculator, you'll get that equals 3. So you have x cubed plus 3 times x, 3 minus 1 is 2, y, plus 3 choose 2. When you put that in your calculator, you'll get 3 times x to the 3 minus 2 is x to the first, y squared. And then plus 3 choose 3 is going to be 1 times x to the 3 minus 3 is 0, so that just goes away, and then y cubed. So when we have it expanded, it turns out to be this. So here we have some practice problems with the binomial theorem. This first one says expand the binomial x plus 4 to the 5th. So I'll teach you a quick trick with this so that you can save time on your test. So we have our first term is x and our second term is 4. So we'll take our first term, x, and raise it to the 5th power because that's our exponent here. And below it, we'll just keep decreasing the exponent by 1. So x to the 4th, x cubed, x squared, x to the 1st, x to the 0. And then we'll do the same thing with our second term. So then we have 4, but we're going to start at 0 and go up. 4 to the 0, 4 to the 1st, 4 squared, 4 cubed, 4 to the 4th, and 4 to the 5th. Then the last thing we need to do is our combinations. So for this first one, we have 5, choose 0. So we'll use the exponent on the second thing. The second one will be 5, choose 1, 5, choose 2, 5, choose 3, 5, choose 4, 5, choose 5. Our 5, choose 0 is going to be 1. So we'll have 1 times x to the 5th times 4 to the 0 is going to be 1. So it's just going to be times another 1. Our 5, choose 1 is just going to be 5. So 5 times x to the 4th. 4 to the 1st is 4, so times 4. Our third one, 5, choose 2 is 10. So we'll have 10 times x cubed times 4 squared, which is 16. 5, choose 3 is going to be 10. So we have 10 times x to the 4th, and then 4 cubed, which is going to be 64. Then we have 5, choose 4, which is 5, times x to the 1st, which is x, times 4 to the 4th, which is going to be 256. And then finally we have 5, choose 5, which is 1, x to the 0, which is also going to be 1, and then 4 to the 5th, which is 1024. So if you notice the pattern here, it starts with 1, 5, 10, and then halfway through it'll flip and go back down to 1. So 10, 5, 1. So that'll happen with all of your combinations when you're going from 0 all the way to the same number as the combination. So now we can simplify this some more. 1 times 1 is 1, so we just have x to the 5th. 5 times 4 is 20, so 20x to the 4th. 16 times 10 is 160, 160x cubed. 64 times 10 is 640. And then we have x to the 4th. 5 times 256 is 1,280. And then we have x. Then 1 times 1,024 is just going to be 1,024. And I accidentally wrote x to the 4th here, but this should be x squared. So this should also be x squared. So then you can see it's counting down. X to the 5th, x to the 4th, x to the 3rd, x squared, x to the 1st, and then x to the 0. So in expanded form, we have x to the 5th plus 20x to the 4th plus 160x cubed plus 640x squared plus 1,280x plus 1,024. So this is your expanded binomial of x plus 4 to the 5th. So now we need to find the binomial coefficient for the following terms in x plus y to the 8th. So here we have x cubed times y to the 5th. X cubed times y to the 5th. And our coefficient is going to be something choose something. So the first number is going to be our exponent, so this 8. So we have 8 choose. The second number is going to be our exponent of the second thing in our binomial, so the y's exponent, so 5. So we have 8 choose 5 of x cubed times y to the 5th. So 8 choose 5, we can use our calculator to find that, and we'll find that 8 choose 5 is 56. So we have 56x cubed y to the 5th. So our binomial coefficient is just this 56 right here. We could also find that by using our n factorial over k factorial times n minus k factorial. So this would be n, which is our 8. So 8 factorial over k, which is the 5. 5 factorial times 8 minus 5 factorial. So we have 8 factorial over 5 factorial times 3 factorial. So these numbers right here are actually your exponents. So this is the 3 and the 5, and then the total, which is the 8. So 8 factorial is 8 times 7 times 6 times 5 factorial over 5 factorial times 3 factorial. We stop at this 5 factorial because this is the biggest factorial we can cancel on the top and bottom. So then that equals 8 times 7 times 6 over 3 factorial, which is 3 times 2 times 1. So we know 3 times 2 is 6, so we can cancel that with the 6. And then we just have 8 times 7 over 1, so that's 56. So that's our binomial coefficient there. So for the second binomial coefficient, we'll just solve it by hand. So we have x to the first times y to the 7th. So our total is 8. So we have 8 factorial over 7 factorial times 1 factorial, because those are our exponents here. So that equals 8 times 7 factorial over 7 factorial times 1 factorial, which is just 1. Those 7 factorials cancel, and so we get 8 over 1. So our binomial coefficient is 8. Next, we'll learn about Pascal's triangle. So it's created by starting at row n equals 0 and creating a triangle of all the possible combination values of n choose r, or n choose k. R and K can be used interchangeably. So sometimes you'll see people use K in their formula, sometimes R, sometimes any letter. It doesn't really matter as long as you keep it consistent between here and here. So this first row of Pascal's triangle is 0, choose 0, because n is 0. The second one is 1, choose 0, then 1, choose 1. The third row is 2, choose 0, 2, choose 1, 2, choose 2. And that'll just continue with an infinite number of rows. So those combinations can be found using the formula n factorial over k factorial times n minus k factorial, or using your calculator by clicking the math button, then moving right to where it says prob, or probability, and then you go down until you see NCR, which is n choose r. One thing that's cool about Pascal's triangle is that the rows below it are a sum of the numbers above them. So this one, the first row, is going to be a sum of 1 plus 0. So this is 1. 1 plus 0 is 1. But then if we take 1 plus 1, we get 2 there. 1 plus 2 is 3. 1 plus 2 is 3. And then we have the 1s on the edge because it's just adding the 1. So 3 plus 1 is 4, 3 plus 3 is 6, 3 plus 1 is 4, 4 plus 6 is 10, and you'll see that that pattern continues. 20 plus 15 is 35. So that's one thing that's really cool about Pascal's triangle, which makes it a lot easier to draw, because you would just write 1, 1, 1. 1 plus 1 is going to have 2 in the middle, 1's on the edge, put a 1 on the edge, 3, 3, 1, and so on. So it makes the triangle really easy to draw. What's interesting about this, however, is that Pascal was not actually the first person to think of this idea, which creates some conflict about ethics and mathematics. Things similar to Pascal's triangle, or the mathematics behind it, were known in several different cultures before Pascal was even around. One example of a mathematician who had basically learned this principle before Pascal is a Chinese mathematician named Yang Hui. I don't know if I'm pronouncing that right, but it's Yanghui. But that's just something to be aware of when using Pascal's triangle. So for practice here, we're going to expand the binomial x plus y to the 7th using Pascal's triangle. So we can look at the triangle and we'll look for row n equals 7. So this is n equals 0, 1, 2, 3, 4, 5, 6, 7. So we're going to use this row. So these will be our coefficients for the terms. So we'll have 1, 7, 21, 35, 35, 21, 7, and 1. And then we'll do our first term, starting with our highest exponent. So x to the 7th, x to the 6th, x to the 5th, x to the 4th, 3rd, squared x, and then x to the 0, which is just 1. And then we'll take our second term, our y, and start at 0, so y to the 0, and go all the way up to 7. So then we have y squared, cubed, 4th, 5th, 6th, 7th. So this is x to the 7th, 7x to the 6th y, 21x to the 5th y squared, 35x to the fourth y cubed, 35x cubed y to the fourth, 21x squared y to the fifth, 7x y to the sixth, and then just y to the seventh, which then you would write out like this, which just takes a while to write. Plus 35x to the fourth y cubed, 35x cubed y to the fourth, 21x squared y to the fifth, 7x y to the sixth, plus y to the seventh. So this is x plus y to the seventh expanded. So here are some more practice problems. So find r when 8 choose r is 70 using technology. So to do this, you're going to go to your y equals on your calculator. And in y equals, you're going to enter 8 choose r. So to enter 8 choose r, you go to math, over to probability, and down to NCR. Then click enter. So the first number you're going to enter is 8, and the second number you'll enter your variable, which will just be x. Once you've done that, you can go to your table to see what the combination would equal for every different value of x. So you'll click second graph, which takes you to your table. So there you can see if x is 0, our combination will be 1. If x is 1, then it'll be 8. If it's 2, it'll be 28, and so on. So it equals 70 when x equals 4. Next we have find r when 12 choose r is 495 using technology. So we'll do that same thing. In y equals, we'll enter 12 choose r this time. Or actually we'll enter 12 choose x because x is our variable, but the letter doesn't really matter. And then we'll go back over to our table. So on your table, you should see that there's 2 different values for x when our combination will be 495. It'll be when x equals 4 and when x equals 8. So you would say r equals 4 or r equals 8. And on this previous problem, we should say r equals 4. So this here shows what should be on your calculator. So here you can see at x equals 4, we have 495. And also at x equals 8 down here, it's also 495. So here we have our first IB practice question, and for this one it's calculator allowed, so we can use our calculator to solve this one. So it says for the expansion of 3x plus 2 to the 11th, A, how many terms are in this expansion, and B, find the term with x to the 6th power. So for how many terms, we'd start with our x to the 11th power and go all the way down to our x to the 0. So we'll actually have 11 plus 1 terms. This x to the 0 would be our 12th term. So we'll say 12 terms. And then it says find the term with x to the 6th power. So this first one right here, the exponent is equal to n minus k. So 6 is going to be equal to our n, which is 11, minus k. So we have n equals 11. So our k value, if we add k to each side, so we have k plus 6 equals 11, and then we subtract 6 from each side, so we get k equals 5. So we have n equals 11, k equals 5. So we have n choose k, and then our first term, which is this 3x to the n minus k, so 11 minus 5, times our second term, 2, to the k, which is 5. So 11 choose 5 times 3x to the 6th, 2 to the 5th. So using our calculator, we find that 11 choose 5 is 462. And then we have 3 to the 6th, which is 729, times x to the 6th, so x to the 6th. And then 2 to the 5th, which is 32. Then we can multiply the numbers together to get 107777536 x to the 6th. So here's our term with the x to the 6th power. So to get full points, you'll want to make sure that you completely expand this and find your final answer with x to the 6th and that whole coefficient before it. So here we have our second IB practice question. It says, for the expansion of 3x plus 1 to the n, the coefficient of the term x cubed is 594n, where n is positive. Find n. So this is a no calculator problem. So we'll start out with our equation. So we have n choose r of our first term, which is 3x to the n minus r, times our second term, which is 1 to the r. So we're going to turn our n choose r into the formula for that. So we have n factorial over r factorial times n minus r factorial times 3x to the n minus r times 1 to the r. So we're trying to find our x cubed term. So this part right here needs to equal 3. So n minus r equals 3. So we know that r equals n minus 3. So we're going to do some substituting. So we have n factorial over r factorial, which is going to be n minus 3 factorial, times n minus r factorial. N minus r is equal to 3, so it's going to be times 3 factorial. And then we have that times 3x to the n minus r, which is going to be 3. And then 1 to the r is going to be 1 because 1 to any power is still 1. So we don't even need to write that down. So now we have n factorial is equal to n times n minus 1 times n minus 2 times n minus 3 factorial. We'll stop there because that can cancel with our n minus 3 factorial on the denominator. And then that's times 3 factorial, which is 3 times 2 times 1, which is 6. And then times 3x cubed. So 3 cubed is 27, and then we have x cubed. So our coefficient for this term is going to be this part here, up to the 27. And it says our coefficient is equal to 594n. So we have n times n minus 1 times n minus 2 over 6 times 27 equals 594n. So to simplify this, we can multiply both sides by 6 over 27, because then we can simplify the 6 and 27 over here and turn them into 1s. And then we'll also divide by n on both sides, so we can get rid of both n's. So we have n minus 1 times n minus 2 equals 594 times 6 over 27. So that simplifies to 132. Now we can expand this using our distribution. So n times n is n squared minus 2n minus 1n and then plus 2 equals 132. So we have n squared minus 3n plus 2 equals 132. We'll set this equal to 0 so that we can factor it. So we have n squared minus 3n. So we're subtracting 132 from each side. So we get minus 130 equals 0. So this right here can factor. So we need two numbers that multiply to negative 130 and add or subtract to our b value, to negative 3. So if we have 10 and negative 13, then those numbers can add to negative 3 and multiply to negative 130. So we get n plus 10, n minus 13 equals 0. So if n plus 10 equals 0, the whole thing will equal 0, or if n minus 13 equals 0, the whole thing will equal 0. So if we solve for n, we can subtract 10 from each side, so we get n equals negative 10, or on this one we can add 13 to each side, and we get n equals 13. So in the problem it says n needs to be positive, so we know that n is going to be 13. In summary, here we have several important equations. So we have the binomial theorem, which shows how to expand binomials, so two-term expressions, to a power using the following equation. So this is the equation here, where our n choose k is the same as this below, where it's the binomial coefficient n choose k. Then we also have Pascal's triangle, which is created by starting at row n equals 0 and going up by 1 with each row and creating a triangle of all the possible combination values, n choose k. So here's the formula for n choose k, which is the same as the binomial coefficient. And then using a calculator, it's math probability n choose r. So this r is the same as k. You can use whatever variable you want to, as long as you keep it consistent in your equations. That's all for this video. Thank you so much for watching.